Chapter 11, Areas of Polygons. Today we're going to cover Section 11.2, Areas of Parallelograms, Triangles, and Rhombuses. Our objectives will be to know and use the formulas for the areas of parallelograms, triangles, and rhombuses. Theorem 11.2, the area of a parallelogram equals the product of a base and the height to that base. So I think of a parallelogram as, it's the same formula as a rectangle, and if you try to figure out why it's the same area as a rectangle, if I imagine taking this triangle right over here, and if I took that piece and just slid it over here so that it was no longer over on this side, but looked at the new shape that I have, the new shape that I have is a rectangle, and the rectangle has a base equal to that of the parallelogram, because I can see that up at the top, and it has a height equal to the parallelogram. So areas for parallelograms just the same as a rectangle, base times height. Theorem 11.3, the area of a triangle equals half the product of a base and the height to that base. So if I look in my picture here, I normally think of the base as the bottom, the height then is telling you how tall it is. So if I looked at the triangles to the right, the base is still going to be on the bottom, but the height I know has to come perpendicular to that base so that it would be straight, telling you how tall. Out here, base is still on the bottom. The height, though, would have to be perpendicular to the base, letting you know how tall it is. And I remember the formula for a triangle by thinking that if I were to take a triangle and sort of make it inside of a rectangle, the triangle happens to be half the size of the rectangle, so the formula should be half of a rectangle, and it's 1/2 base times height. Find the area of each figure. A triangle with base 6.3 centimeters and corresponding height 9.8 centimeters. So they're telling me the two important pieces of information, the base and the height. So I can go right to the formula. Area equals 1/2 times the base, which is 6.3 centimeters, times the height, which is 9.8 centimeters. And now I just have to multiply this stuff together. So grabbing a calculator, since I have the decimals, and let's see, so 1/2 I know is 0.5 times 6.3 times 9.8, and I get 30.87. And the unit centimeter times centimeter would be centimeters squared. Number 2, a parallelogram with a base 4 squared root of 3 and corresponding height 5 squared root of 3. And similar to the last one, they're telling me the two important pieces of information. I have the base and I have the height, and I know the formula is base times height, so it's going to be base 4 square roots of 3 times height 3 square roots of 5. And when I go to multiply this, I just think of multiplying the corresponding parts. So I'm going to multiply the numbers out in front. 4 times 3 is going to give me a 12. Then I'm going to multiply the numbers that are under the square roots together. So a square root of a 3 times a square root of a 5 is going to give me square root of a 15. And there weren't any units, so I don't worry about any units on my final answer. Number 3, an isosceles triangle with sides 12, 12, and 10. So let's see, if I make myself an isosceles triangle, and the sides are 12, 12, and 10. So I know the formula is 1/2 base times height, and I know I have a base of 10. So what I really need to figure out is, what's this height inside? Well, I know if it's an isosceles triangle, if I draw in this altitude, it bisects the base so that this is really 5, but I need to know what the height is. Well, I have a right triangle, so I could do Pythagorean theorem to figure out what that height would be. So going through Pythagorean theorem, I get 5 squared plus 8 squared equals 12 squared. Well, squaring, I get 25 plus 8 squared equals 144. Subtract off the 25, 8 squared equals 119. I need to square root each side. And I get that the height equals, and now I have to think of, can I simplify the square root of 119? Well, if you're not certain, just grab your calculator and see if 119 is divisible by numbers you know the square root of. Well, I know the square root of 4, and 4 isn't going to go into there. Is it divisible by 9? And it's not. Is 119 divisible by, I know it's not divisible by 25. Is it divisible by 36? And it's not. And it's going to just have to stay the square root of 119. So now I have my height, so I can get my actual area for this triangle. The area equals 1/2 times the base, and I know the base is 10, times the height, and the height in this case happens to be the square root of 119, and half of 10 is 5, and the square root of 119 isn't going to change. Number 4, I have a parallelogram, and I can see that by looking at the entire bottom down here that I have a total base of 12, which I'm just going to write up here at the top. But I need to know what the height is. So I'm really looking for what's this vertical piece right here. Well, if I want to get that height, in this case I notice that I have a 30, 60, 90 triangle over on that side. And if I have a 30, 60, 90 triangle, and I'm going from the base to this altitude, I just multiply by the square root of 3. So this height here is going to be 2 square roots of 3. So now into the formula. I know the area for a parallelogram is base times height. The base is 12, and the height is 2 square roots of 3. So 12 times 2 is 24, and the square root of 3 doesn't change. Number 5. I see it's a parallelogram, so I know it's base times height. I know the base is 9, but I don't know the height, so I imagine drawing it in. Definitely not drawn to scale. There's a 45, 45, 90 triangle. So I know that if I go from the hypotenuse to one of these legs, I just need to divide by the square root of 2. So taking the 6, divided by the square root of 2. Can't leave the square root of 2 in the denominator, so I rationalize it and multiply by square root of 2 over square root of 2. That leaves me with 6 square roots of 2 over a 2. And then if I divide, I end up getting 3 square roots of 2. Now on to my formula. So parallelogram is, area is base times height. My base is 9. My height, I figured out, was 3 square roots of 2. So my final area, 9 times 3 is 27, and square root of 2 has no change. Number 6. I noticed that there's 3 separate shapes in here. I'm going to call them shape 1, 2, and 3. I notice the end pieces are both triangles, and they're the same size, and then in the middle I have a rectangle. If I look at shape 1 and 3 right now, I can see that they're triangles. I know the base is 8 and the height is 8 because they're forming the 90-degree angles. So right off the bat, I'm just going to say the area of shape 1, which is a triangle, is 1/2 the base of 8 times the height of 8, which gives me 32. Okay. The area of shape 3 is the same exact triangle, so I'm going to get the same exact area of 32. But now I need to find the area of shape 2, that middle rectangle. I know the base is 10, but what I'm really looking for is, what's this height? Well, to figure out the height, I'm going to look at the triangle over on the side. I notice that it's an isosceles triangle, and it's also a right triangle. And if I have an isosceles right triangle, I know it's a 45, 45, 90 triangle. So this is a 45-degree angle. And if I go from a leg to the hypotenuse in a 45, 45, 90 triangle, I just need to multiply by the square root of 2. So this side is 8 square roots of 2. So now when I find the area of that middle shape, I end up getting a base of 10 times a height of 8 square roots of 2. And if I multiply that together, I get 80 square roots of 2. And now to get the total, I'm just adding everything up in the column on the right. Well, here's the first thing I notice. The 32 and the 32 I can add together, they're just plain numbers. The 80 square roots of 2 has a square root of 2 attached to it, so I can't add it to the other numbers. So when I put all of this together for my final answer, 32 plus 32 is 64, plus, and then I have the 80 square roots of 2. So final answer, 64 plus 80 square roots of 2. Number 7. I have an equilateral triangle and a side is 9. Well, I need the base and the height. So the first thing I notice is if it's equilateral, my base is also 9 because all the sides are 9. The next thing I need to figure out is what is this height? Well, I know if it's an equilateral triangle, all the angles were 60. So this is really now a 30, 60, 90 triangle if I look at just one of the halves of the original triangle. So let's see what happens. I know if the entire base is 9, that half of the base is going to be 4.5. And I know that in a 30, 60, 90, if I go from the small side to this piece right there, it just gets bigger by the square root of 3. So that's really going to be 4.5 times the square root of 3. Now for my final answer. I know that the area of a triangle is 1/2 the base, and the entire base is 9, times the height, which is 4.5 square roots of 3. Now multiplying all of this together. Well, I'm going to multiply all of these leading numbers out in front, and the square root of 3 portion isn't going to change at all. So let's see what happens if I multiply the 0.5 times the 9 times the 4.5. So just going to my calculator. 0.5, or the 1/2 I know is 0.5, times 9 times 4.5 gives me 20.25. And then I still have the square root of 3.